Hello everyone. Today I will be taking you all on a journey to understand the steps involved in linear regression algorithm. And this video is going to be completely animated. Detailed video will be uploaded later in this playlist of machine learning algorithm. This is just a short introduction. Now let's get started. What if I told you that your phone predicts your next word using the same mathematics that Netflix uses to recommend the show? It all starts with something beautifully simple, a line. Imagine you have a scattered data points and maybe it can be weight and height of a person, or it can be house sizes and their prices. Our goal is to find the line which best fit this data. As you can see on the screen, we are trying to find the best fit line. This is linear regression, the foundation of machine learning. Now, every line we know has a story which is told by two numbers. Here you can see those two numbers as theta naught and theta 1. X is called the independent variable, where x theta of x is the dependent variable. Theta 0 is called the y-intercept. That means we can get the value of theta naught by substituting x equal to 0. In this visualization, whatever distance the line cuts along the y-axis is called the y-intercept. And theta 1 is nothing but the slope, which is the measure of steepness. Or in the term of y and x, it is the change in y as we change the x value by 1 unit. Change this number and you can change the reality. That is the essence of slope in linear regression. Now, to find the best fit line through the given data, our first guess is always usually wrong. See this scattered data points, and this is our line which we are trying to find out, denoted by x theta of x. Now see this vertical line. These are the distances between the actual point, which are the cross ones, and the predicted point, which lies on this green line. Our aim is to minimize these distances. And for this, we have this expression of the cost function, which is nothing but the average of the square of the distances between these two actual and the predicted point. Our aim is to minimize that distance. The line which gives such value of cost function, that will be the best fit line in our case. Now, to find out that best fit line, we keep on changing the value of theta 0 and theta 1. Let's take theta 0 as 0 and theta 1 as 1. We will get the line as theta of x equal to just x. Now, these are the data points, actual ones, and this is the line which we are going to get. Now, if we plot or try to find the distances between these two actual and the predicted points, we are going to get the value of the cost function as 0.34, which is usually high. Now, let us change further the value of theta 0 and theta 1. We have taken theta 0 as 0.8 and theta 1 as 9. And again, we do the same thing, find the distances between the actual and the predicted point. We get the value of the cost function as 0.28, which is lower than the first iteration value. We just keep on doing this iteration till our cost function is minimized. That line will be the best fit line. Similarly, in the third iteration, if we calculate the value of the cost function, that comes out to be 0.31. So, as we go on doing this, we are going to find out finally the best fit line. Now, if we try to plot the graph of the cost function versus the value of theta, we are always going to get a parabola in this case. And this is a global minima of this parabola, which is denoted by the green dot. If you plot those, we have taken 3 iteration and we got different values of the cost function. J1, J2, and J3. J3 is closer to zero, sorry, not zero, but it is closer to the global minima, which is our aim. So we say that the line corresponds to the cost function J3 will be the best fit line. Now, we keep on iterating this step using this expression, as you can see here, which is repeat the steps until convergence to the global minimum. Now, one important factor is to decide the value of this alpha, which is the learning rate. Now, to find out the value of the learning rate, it is usually advised to take the value not too small, not too large, but just enough so that our aim to reach the global minima is fulfilled. Let us take a point on the left parabola, which you can see here denoted by the blue dot. Now, if we have taken the value of the learning rate to the smaller 0.1, slowly we will be reaching towards the global minima and our goal is fulfilled. If we take on the right hand side the value of the learning rate to be large enough as 1.8, we might be skipping the global minima as our G theta will be oscillating fast on the parabola and it may skip the global minimum. So it is not advisable to take larger values of the learning rate. So this is all about the machine learning algorithm. This was just a short introduction using visualization. Detailed video will be uploaded on this channel in this playlist. Hope you understood and you must be curious to know more. Let's meet in the next part of the video. Thank you for watching.